Okay, so for today's lesson, you need this paper from your packet. So it says filling and wrapping 3.2. Okay, and it should be this paper attached. You might want your calculator, maybe a straight edge. Actually, we'll find out later. We actually don't need a straight edge, maybe. And then let's see. You need to make another graph. And sorry, I didn't put another piece of graph paper in here. So what I'm thinking you could maybe do is if you just take your graph paper from yesterday, if you turn it over, you can probably see through it enough. I know you can't see through on mine enough, but you could probably see through it enough that you could just draw on top. Or I've attached in the instructions a copy for it if you've had a printer at home. But if not, don't worry about it. Just go ahead and turn this paper over to the back, and I think it'll probably work. Okay, so do you remember what we were supposed to learn yesterday? So that on any circle, no matter how big or how small, okay, if you take any circle, okay, and you measure the distance across, that's called the diameter. How many of these diameters will fit around the outside of the circle? Well, pi of them, so a little bit more than 3. So basically the circumference is equal to the diameter, which is so much more easier to measure. Like, okay, pull a ruler out here and measure that versus, okay, I'm going to try and measure the distance around. Okay, this is kind of crazy. Okay, so a lot easier to go ahead and just try and measure across and then calculate the distance around. So the circumference and distance around could be found by taking the diameter and multiplying it by pi, okay, which is approximately 3.14. Okay, so what we're going to try and figure out today is something about the area of the circle. So remember earlier this week we said area is the amount of space inside of an object. Okay, so we're going to see if we can figure out something about area. Okay. So what I want you to do is to take this lab sheet like so, okay? And I want you to, I put some of the pizzas on the front and the back. Okay, so I know these are really not to scale, but part of the question if we were doing this book, if this were a square inch and they were some different size pizzas, how much area would you get from these different size pizzas? So I just want you to do, as best you can. So I want you to look at the small one and how many squares do you think are inside? Okay, then I want you to look at the medium, see if you can figure out about how many squares are inside. Same with the large, extra large, and the extra, extra large pizza. Okay, so I just want you to fill out this by estimating how big the area of each of these would be. Okay, using any kind of method you want. Okay, so when you estimate the area of the small pizza, did you get something around 28-ish? So there's a couple ways you could have done that. You could have said, well, okay, let's see. I'm just going to sort of count this. How many whole squares are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've got about 17, 18, 19, 20, 21, 22, 23, 24. And then some of these partial squares. You see how about 28 of them fit in there? Okay, so that's one way you could have done it. You could have said, oh, okay, well, I know the area of this rectangle right here that goes around it. Let's see, this is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. It's got to be less than 36. Okay, so you could take 36 and maybe cut off some of these parts. If I subtract, let's see, 1, 2, 3, 4, 5, 6, 7, 8 off of my 36. Okay, I get about 28. So that's maybe a way you could have done it. If I look at the other shapes, the medium should have been around 64, the large around 113-ish, and the extra large around 177. Okay, and extra, extra large around 314. And don't worry if you didn't get those exact numbers, okay, because we were just trying to estimate the area, so about how many squares are inside. Okay, So I kind of, if we were doing this in class, we probably would have shared some different ways that students could have found the area, by just straight up counting, or, maybe some students might have said, okay, well, I'm not going to count all this. That'd be kind of cray-cray. I'm going to go ahead and just take like this, and I'm going to divide it into 4 pieces, and I'm just going to count like this part and then multiply it by 4 to get about how big it is. Okay. All right, so let's go back and take some measurements from each of these circles. So I want you to go ahead and look at the small circle, and we're going to go ahead and try and find the diameter. Okay, so you're going to count how many blocks across. Looks like it's 1, 2. So how many length? 1, 2, 3, 4, 5, 6. So on my paper, I'm going to write that the diameter of the small circle was 6 inches. And remember, this is to scale. Each of these blocks are supposed to represent an inch. The radius, we learned that the other day, is the halfway point. So that must be 3. Okay, and then I'm just going to maybe just use my numbers from up above. If you were quite a bit off of that, the area was about 28. So I want you to go ahead and try and fill in the rest of the chart. Okay, so when you filled in the rest of the chart, did it look something kind of like that? So the distance across on the medium circle should have been 9, halfway 4.5, about 63. The large all the way across 12, halfway 6, 113. Extra large 15 blocks across, halfway 7.5, and then 177. Extra large 20 across, radius was 10, halfway, so 4, 3, 14. Okay, so next it says make a graph of the radius versus area. Label the radius on the horizontal axis and area on the vertical. Okay, so remember what I said, how you could just take that graph paper from the other day and maybe just try and flip it. Oops, not that one. Flip it over and use the back. Okay. Or if you printed one out, okay, you could probably just use that. Okay, I'm going to grab one more. Okay, so, all right, so we're going to try and set this up. And I know I didn't want to turn mine over the back because I thought it'd be really hard for you to see, but you could just be working kind of on the back and then using those lines if you can sort of see through. Okay, so on the bottom of my graph, I'm going to go ahead and put the radius of each of my circles, and then on this side I'm going to put the area. Okay, so, and I think if you set it up so the radius, since we just had to go up to 10, I think we can use this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then the area, my biggest area was a little over 300, wasn't it? So I'm not going to be able to use just blocks of 1 here, or I'll just be way off for that. Okay, so I think I'm going to make, this be a 50. Okay, so that means like that 2 blocks are 10, 20, 30, 40. So I'm going to put 50 here, 100, 150, 200, 250, and 300. Okay, so and then what I want you to do is to graph the radius with the area. So go to radius of 3 inches and then area, and go ahead and plot those points. Okay, all right, so you should have gotten something that looks kind of like this. So radius of 3, we're going to go up to 28, so about so. Radius of 4.5, we're going to go to 63, so about kind of so. And then radius of 6, 113, kind of here. Radius of 7.5, let's see, we got 177. Okay, and then radius of 10, 3, 14. So it should kind of look like that. Okay. All right, so then go ahead and turn your paper over the back, and you're going to answer a couple questions. Okay. And the first one says, would a line be a good model for this relationship? So if I put a ruler down, you think that would be a great model for this? Okay, well, hopefully you said no. Okay, and why? Looks like the points are definitely making this kind of curve. Okay, so points curve. Okay, so they were not in a very good straight line. Okay, is this relationship a proportional relationship? Hopefully you said no. Okay, so why? Even though, you know, probably starts at 0, 0, if we've thought about this pattern, you know, it's to be proportional, it has to be starting at 0, 0 and making a linear pattern. So like in looking at the chart, so if 3 was 28 and if it was proportional, then 6 should really be double that, and it's not. Okay, so it's not the same proportion or in the same ratio. Okay, so it's definitely not a proportional relationship. If I divide these numbers, I'm not going to get the same unit rate. Okay. All right. So let's see. Next question is a curve. Okay, so I guess proportional, no, it's not linear because that's the first requirement. Okay. A curve would probably be a better model for this relationship. Draw a curve that comes close to all of your points. Should it go through 0, 0? Okay. All right, so I'm going to give you a chance to do that. Hopefully I already kind of answered that question. It should go through 0, 0 because if you had a radius of 0, it would have no area. Okay, so I'll give you a chance to do a curve. Okay. When you drew your curve, did it then make your graph look somewhat kind of like this? Oh. Yep. Man, need some curve practice, huh? Okay, so then we're going to answer a couple of questions. So curve would be better, so we drew it. Should it go through 0, 0? Yes, and I hope I explained that okay. And a radius of 0 should have an area of 0 also. Okay. All right, so it says use your curve to predict the area of an object with a radius of 8. Okay, so we're going to head to 8, head up to here. It looks like it's maybe a little bit over 200-ish, around 200, or maybe a little bit more, maybe. Okay, circumference. Use your curve to predict the, oh my goodness, I put circumference, seriously? So I meant to say radius. Okay, so use your curve to predict the radius of an object with an area of 200. Okay, so I head to 200, head down. Okay, mine looks like it's about 8 or so, doesn't it? Well, I guess because that's what I got here. Goodness me, I should have picked some different numbers. Okay, can you think of a way to find the area if you know the radius without using your graph? Write your thoughts down below. Now, this is a pretty hard pattern to see, so I think I'm going to have to just kind of show you. If I look back at my chart on the previous side, okay, there is a relationship between the radius and the area. It's pretty hard to see. If we were in class kind of talking about it a little bit, I'd probably take you through this. You know, it's a circle. It's got to have something to do with that magic number. What's that magic number? It's pi, okay? So maybe you can see the pattern if I do this. I'm going to take 28 and I'm going to divide it by 3.14, okay? I end up getting about 9. Okay, I'm going to take 63 and also divide that by 3.14. Okay, I end up getting about 20. Okay, so I'm going to take 113 and divide that by pi. And that's 36 about. And I'm going to take 177, divide that by pi. And I end up getting 56. I'm going to take 314 and divide that by pi. I get 100. Okay, maybe you see the relationship. There's a relationship between this number and this number. Let's see, 10 and 100. What do I know about 10 and 100? Oh, well, 100 is just 10 times 10, isn't it? Okay, that's kind of good to see. All right, how about 3 and 9? Oh, that's just 3 times 3. Oh, how about 6? 6 and 36, that's just 6 times 6. Oh, cool. So I wonder if this is 20 is about 4.5 times 4.5. Yep, pretty darn close, isn't it? Okay, so I wonder if 56 is about 7.5 times 7.5. Yeah, pretty close, isn't it? Okay, so this is really cool. If I wanted to find the area of any circle, instead of doing all this crazy counting inside or making a graph and then trying to estimate it, if I just took the radius times the radius, which is pretty easy to measure, probably diameter is the easiest, and then find the radius. But if I take the radius times the radius and I multiply it by my magic number of pi, isn't that totally cool? I get the area every time. Okay, so the area of any circle can be found by multiplying the radius by itself and then multiplying it by pi. So that's what we could write on the back. If I just take the radius times the radius and multiply it by pi, I will get the area every time. Here's like another kind of cool way to think about it. If I look at this circle, if I go ahead and draw this like kind of square here, okay, how big is that square? Well, that square can be found by taking the radius times the radius. How many of those squares do you think fit inside? Well, definitely not 4. And really, a little more than 3. What's the magic number? Pi. So radius times pi will give you the area of any circle. Isn't that totally cool?